Hello there, and welcome back to Expert City. Today's video is going to be about the common pitfalls that you experience when you're going through various ML algorithms and what you can do to avoid them. Now, if you've done ML algorithms for a long time in the past and perhaps completed 6 to 7 different algorithms on different datasets, then you've probably figured out all these rules the hard way by sitting and then coding and then realizing your mistakes. But if you're a first timer, let's say you're coding your first or second ML code and you have no real idea about what could go wrong in the various steps moving on to the output, then you use this. In order to make this video more usable for you, I'm going to split it up into several chunks. We're going to start off in sequence with the data collection part and then move on step by step, processing the data, cleaning the data, getting to the next stage, which is the ML algorithm, getting everything ready, such as the dataset loader, and then moving on to getting the output. How do you measure the outputs? How do you save the various epochs? And what do you do next once you've completed your project? At each stage, you'd be surprised to see how many ways you could simply fail. And by going through all of this, hopefully on your next mission, you're going to end up succeeding without any of these pitfalls and save a lot of time. So, cheers. Let's start at the thing that people hate the most, numero uno, data cleaning. Now, we have a lot of real-world datasets that we tend to use on our ML algorithms. The problem with almost all of them is that they are not perfect. There are human errors while annotating and labeling data. The images might be of bad quality if you're working with object detection or so on. And so our primary objective is to make sure that our dataset is ready for the algorithm. Most people hate this step. I know, even I do that too. I just hate sitting through tons and tons of Excel, CSV files, changing the datasets which are wrong, altering them so that they are more accurate. But this is important. And if you think about it, without the data, there's no real ML, there's no real data science at all. And so what people don't realize is that they should spend the bulk of their ML project on getting the data ready. Most of us get data from Kaggle and let's say GitHub or some other open source links. And you also get your codes from the same links. And I have seen many people do their first project as an amalgamation of the datasets from one code and the code from another section. So for example, you have a dataset of cats and you're trying to use an ML algorithm which was done on a dataset of the images of dogs and you're trying to get similar results. That's usually our first project, isn't it? And so our objective would be to make sure that the dataset is ready, and not just ready, but also in the style of the dataset that was used for the other code. Now we have various formats for data, and the most common ones are, let's say, Pascal VOC amongst all of them, which has the top corner and the width and height, if I'm not wrong, X, Y, W, and H for each bounding box, and this is for object detection. Now, the problem with that is, if you use a different convention for your coordinates, let's say you find the top left and bottom right coordinates, and then you pass it into the ML algorithm, you're going to get different boxes for training, which means you're obviously going to get bad results, or bad, even terrible results. To avoid this, you have to make sure that you thoroughly understand the data was used on the previous code if you are taking something from a different code, or you have to make sure that whatever ML algorithm you write is able to take the inputs that are provided from the dataset and pass them properly to get the desired results. If you do not do this, you are going to face a lot of problems. Believe me, I have. And the first thing you want to do while you're doing this is remove noisy data. How you do this is an important question. Do you put a limit, a threshold value saying if it's not of this confidence, do we remove that value? Do you manually remove the data, which might be very time consuming? Or do you create some code that highlights the incorrect data based on some metrics and then remove them or modify them accordingly? These are questions that you'll have to answer for yourself, And as I've said before, this video is not about answering those questions, but to present those questions to you so that you can find your customized solutions for your own code. Now that we've walked through the data pre-processing part, we're now going to look at the code itself. Now, what does our ML code usually have? We have the dataset, the data loader, and then the code. I'm going to talk about PyTorch in this particular video, but you could be using TensorFlow or any other framework out there to get the desired results. The idea is generally the same and can be implemented in these other frameworks as well. Now, what is it that we'd like to do with our code to make sure that it's ready? First, when you load the dataset, try and understand what the code for the training actually requires. Most people starting out on ML use pre-trained codes, particularly pre-trained on, let's say, the MS Coco dataset, which is widely available. And to do that, you have to understand that they have particular requirements for the inputs and they give the outputs in one particular form. Let's leave the outputs aside for now because that would be the next stage of our code. But at least for the input side, you have to make sure that the dataset part and the data loader part get the data that we previously got and then ensure that they are acceptable for the training code. Because if not, there are going to be errors again. And this is very important because, again, this is a framework that we directly take in and we add in the different elements to it. So we are talking about, let's say, our usual Python code with the images, the box coordinates, the labels, the targets that we want, and we drop them directly into the mix. And we just hope that the training algorithm takes care of all of this. And because of this mix and match, pick and drop method that we have available for us, we have to make sure that whenever we pick and drop, the previous section amalgamates with the current section. And that's it about getting the training right. And another major error that you might find with this is that we tend to have something called an epoch problem. So here the main idea is that, let's say you're running with 100 epochs or 100 iterations, and usually it's as if the nth epoch performs worse than the n+1 epoch, which performs worse than the n+2 epoch. But that doesn't have to be the case, right? In some cases, the 15th epoch might perform better than the 20th epoch. You never know. And so it's important that while you save each epoch creating a checkpoint model, you save the best version and not the latest version. By doing this, you ensure that you always have the most accurate results. To do this, you generally require a performance metric. Now, most preloaded training codes do not have this, so you have to come up with your own way to measure the metrics and then save it if its performance score is greater than the previous score of the previous epochs. That way, you ensure that the best model is always saved instead of the latest model. Once that is done, your training part is pretty much complete without any major errors, and we can move on to the testing and whatever happens next. Now that your training is done, it's time to enter the final quarter. What do we have left? Not much really. We just have to get the training right and then move on to measuring the accuracy of our model. We can then test it on an image, or in your case, if it's not object detection, if you're not dealing with image, whatever it is, an audio file, or so on. The question that comes first is, how do I split the testing and training datasets? Now, usually, when there's a test, train, and validation sequence, training tends to have around 65 to 70% of the weightage. The remaining is distributed equally between validation and testing. Now, this works for large datasets, but what if you have a small dataset? There are many methods for this, such as the k-fold method, or you can just go through these on YouTube. These are pretty simple, straightforward. There are also great textbooks on data science that explain the same topics. The basic idea, though, is that you want to make sure you test these data sets enough, because the training tends to overfit, and you want to make sure that this does not happen in your case, because once you overfit data, you are going to fail in the long run, especially when it comes to testing completely new images. Afterwards, you also want to make sure that you account for distortions in images and other such parameters. Now, you could have done this in training, but you could also do this in testing. If you plan to do it in training, you have to put it in the previous part of the code, in the training part of the code, wherein you add, let's say, the albumentations package for images, which directly modifies the images, changes the brightness, the contrast, and so on. Or you could use it in testing, which is what I prefer to use, in which case you make sure that your algorithm trains from normal images, but tests on distorted and grayscale versions of images. Once you're done with that, what do you do next? Your model is ready. You can take an image or take an audio file or whatever your input is and get the desired output. Is that the end of the line? Of course not. We have to make sure that our application is usable by any new customer. How do we do this? We create a simple user interface, and this usually doesn't have to be something fancy. I mean, you could go ahead and spend a lot of time creating a JavaScript-based version for the browser, but you could also just make a simple Jupyter notebook that takes the input. For example, it has a button that allows you to select the image or the audio file as the input, plus the ML in the background, and then gives out the output directly on screen. So that this way you have a system wherein someone with zero ML experience, zero knowledge about what's happening inside the code, can use the application. That's what tech is all about, making sure that non-tech people are able to use tech applications. This shouldn't take too long. Once you have the PDH file ready, if you're using PyTorch or the equivalent in TensorFlow and Keras, you can directly import, allow the input to come in, run it through the data loader and the data set, and then run the PTH file to get the desired output and just publish it. A print on the screen should be enough, or if it's an audio file, just an audio recording of that where you can just hit the play button and listen to it should be fine, so that they can download it and use it as and how they wish. Once you're done with the web app, it's time to publish your work. Publishing is great. It's your way of putting out what you've done, all your hard work, onto the internet for people to see. It's your way of also showing off of what you've done, your knowledge and your skills. And once you do that, you're done really. That's all that there is to do in this. And with that, I am going to end my video on a positive note and hope that you really succeed in your next project. Goodbye.